Yeah, before getting into some method of solving integration and all, let me quickly list out some formula. Is that okay? That's the best idea. I hope you you already have this one, because I have to recall myself. Okay, I too don't remember much of them. That's why let me list out some of them here. Okay, so let me start with this one: integral of x power n dx. Isn't it? That's equal to x power n plus 1 by n plus 1. Let me put some number. Okay, plus c. Let me quickly note down some of them. But n should not be equal to, so in this case, n should not be equal to minus 1, isn't it? So if n is equal to minus 1, that means 1 by x dx, that's equal to log of x plus c, isn't it? We better write log of mod x. Why? Log of negative quantity is not defined. Log of mod x plus c. Is that okay? So third one, quickly. Yeah. Integral of e power x dx. That's equal to e power x only. E power x plus c. Suppose I better write this one, e power ax dx. That's equal to e power ax divided by a. Isn't it? That's the most general one. So similarly, integral of a power x dx. That's equal to a power x into a. Again, differentiation is a power x into log a. Am I right? Integration is a power x by log a. Isn't it? As a so reverse process. Fifth one. Integral of sin x dx. Be careful. We do very silly mistake here. Isn't it? Integral of sin x dx is minus cos x plus c. Isn't it? Because cos x differentiation is minus sin x. So that one more negative sign to compensate that one. Integration as a reverse process of differentiation. Integral of cos x dx, that's equal to sin x plus c. Don't do any mistakes here, okay? Again, avoiding silly mistake is also very major part in our multiple choice exams, okay? Because silly mistakes will kill the exam actually. If 2 to 3 silly mistakes happen, you will be out of the competition. You know what is the competition, isn't it? That's why no silly mistake should happen. Is that okay? Now, direct sine cos is over. Direct tan and cot is quite difficult to think in a reverse way. But we can think of secant square and cosecant square. Am I right? Integral of secant square x dx. Because tan x differentiation is secant square. That's why that's equal to tan x plus c. Similarly, integral of cosecant square x dx, that's equal to minus cot x plus c, because cot x differentiation is minus cosecant square x, isn't it? That negative sign should be compensated. Is that okay? Again, if you are getting bored, you better to join after some time, okay? But don't miss this one, because later I will explain some more method, infinite integral and all that is needed for all, okay? So ninth one. Secant square, cosecant square, secant x into tan x. Integral of secant x into tan x dx, isn't it? Secant x, am I right? Secant x differentiation is secant x into tan x. So am I right? Secant x differentiation is secant x into tan x. That's why integration of secant x into tan x is secant x plus c. So similarly, integration as a inverse process of differentiation. That's what we are thinking. So integration of cosecant x into cot x, that's equal to minus cosecant x plus c. And sine hyperbolic, cos hyperbolic. Am I right? Sine hyperbolic x dx, that's equal to cos hyperbolic x plus c. Integral, no negative sign here in hyperbolic function, because differentiation of cos hyperbolic is sin hyperbolic is cos hyperbolic. Okay, so just remember this one. So integral of cos hyperbolic x dx, that's equal to sin hyperbolic x plus c. These are very simple formulas. Again, why I have written, because I too forgot formula, that's why. So this is for myself. Okay, I hope you have already done these things. Yeah. So next one is integral of tan x dx. That's, again, we need to think little more, isn't it? That will be log of secant x. Because secant x, if you do log of secant x, if you do differentiation, 1 by secant x into secant x into tan x, secant x will get cancelled, isn't it? Like that. So 14 integral of cot x dx. It should be positive. Ln means log to the base e. I hope you know that one. Is that okay? Log to the base e, we write it as ln. So similarly, cot x dx. So log of sin x, I think. Am I right? Plus c. Log of mod sin x, because 1 by sin x into cos x, isn't it? Into, so differentiation of sin x, cos x. 1 by sin x into cos x, that's cot x, isn't it? Like that. Now again, I need two more here. Integral of sin inverse x dx. Integral of sin inverse x dx. Wait a second. Tan x is over, wait a second. Tan x, cot x is over 15. You better take these things. Secant x, that's equal to log of mod of secant x plus tan x. Quite difficult to think in as a reverse process. Okay, so 16th. Integral of cosecant x dx, that's equal to log of mod of cosecant x minus cot x. Is that okay? Cosecant x minus cot x. So in this, again, somewhere in the problem later, it will come here. Okay, so this kind of integral will come again plus c. So that's why you better to have one more way. Cosecant x minus cot x can be written as tan of x by 2. Okay, you better remember this part plus c. And sum inverse part 17, sum inverse integral of dx by root of a square minus x square. Actually, you can do it by substitution, but you better remember directly. What is this one? Sin inverse of x by a plus c. Similarly, integral of dx by a square plus x square. What is the substitution? X equal to a tan theta. If you substitute, you will get the answer, isn't it? So that's equal to 1 by a tan inverse of x by a plus c. Don't forget that 1 by a. Okay. So similarly, integral of dx by x root of x square minus a square. X square minus a square. That's equal to 1 by a secant inverse of x by a plus c. Actually, this listing is never ending process, but let me list out some important part. Integral of dx by a square minus x square. So that's equal to 1 by 2a log of x plus a divided by x minus a plus c. Integral of dx by x square minus a square is equal to 1 by 2a. Yeah, what is the difference? Only one negative sign, am I right? You can change one negative sign. You don't have to do this one, isn't it? This will be reversed. Log of minus, so that will be reversed. Again, that's not any different one, isn't it? Not any different one. I think here some hyperbolic function substitution you should do, isn't it? Then you have to convert that one into log. I told some hyperbolic inverse that can be written in terms of log. So you have to do it like this. So if it comes in our problem solving, then we shall worry about that one. Is that okay? So that's what I'm thinking. Rather than by hearting all of them, you may get into pressure. Okay. And again, so some more again important part. Integral of dx by root of a square plus x square. Root of a square plus x square. Okay. So that can be written as ln of mod of x plus root of a square plus x square plus c. I found this one in some problem. Okay, that's why I'm just listing out. Again, I have sent all possible integration like this. Keep that one. Whenever we need, we can revisit that one. Okay. So like this, let me list out some more. So integral of x dx whole divided by x square plus a square whole power 3 by 2. So that's equal to minus 1. This is very frequent in electromagnetic theory. This integral. Is that okay? Plus c. So similarly, integral of dx whole divided by x square plus a square whole power 3 by 2. Again, x equal to a tan theta. Let me do that problem. Okay. X equal to a tan theta is the substitution. Okay. If possible, if anyone. So this is equal to x by, I think, a square. Am I right? So we shall do this problem. Root of x square plus a square plus c. You better to remember this one, e power ax into cos bx dx. Very, very frequent. Is that okay? E power ax into cos bx dx. That's equal to, again, it can be done by integration by parts, but quite lengthy. E power ax by a square plus b square, a cos bx plus b sin bx. Actually, let me tell you how to do this one. Okay, you can write e power ax into e power I bx. E power I bx can be written as, again, your Euler formula. E power I theta cos theta plus I sin theta. You can then split that one. You can compare real and imaginary part. Let me do that. Okay, we shall do that kind of. I mean, if you forget that one, then how do you do that one very quickly? That's the idea. Or you can write cos bx in terms of e power I theta, and the exponentials are very easy to integrate, and then also you will get the same answer. Okay, yeah. So similarly, integral of e power ax into sin bx dx, that's equal to, yeah, put plus c here. Okay, e power ax divided by a square plus b square, a sin bx minus b cos bx. Now look at here. What you have to do is look at here. So take this integral e power ax into e power I bx dx. Do that one and separate real part and imaginary part. Suppose if you know the answer, separate real part and imaginary part. Now in this side, look at here, I can write this one as e power ax into cos bx plus I sin bx dx. Am I right? First part is e power ax into cos bx dx. Second part is I into e power ax sin bx dx. Then you can compare the real and imaginary part of this part, and so left hand side and right hand side, you can form these two formula quickly. Suppose if you feel that, so remembering that one is quite difficult, that okay, you can follow this one. Okay, so do this one. Again, using this one, try to prove these two. That's the nice idea. Is that okay? Using this idea, I hope you got the idea. Is that okay? Do this one as exponential, e power ax plus ibx. Do as exponential, then try to separate into real and imaginary part. Okay, that's the best idea. Yeah, so DI method, we shall discuss the DI method now. Okay, I mean, I think I have shared one video right now just before, isn't it, on DI method, again on integration by parts actually. So before getting into some particular method of solution, I am just trying to list out some formula which better to remember rather than doing solution. Okay. Yeah. So you better to remember this kind of integral directly if possible. Okay, if possible. I am not suggesting strongly if possible because it is very frequent in quantum mechanics. Integral of sine mx into sine nx. Sine A sine B formula, isn't it? Sine A sine B formula, that will be, I think, cos A plus B cos A minus B, and after integration again that becomes sine A plus B sine A minus B, isn't it? So you better to remember this one. Again, m and n are usually integer. It happened to be integer in our quantum mechanics actually. Again, we have this kind of integral, so that's why that's equal to sine m minus n x whole divided by 2m minus n, okay, minus sine m plus n x whole divided by 2 times m plus n plus c. Integral of cos mx into cos nx, and fill out this one yourself. Integral of sine mx into cos nx. Fill out these two yourself. Keep a space. Do it later. Is that okay? Fill out these two. You better to remember this formula directly. If you can remember, it's better. That's what I'm suggesting. Let me start with integration by parts. Okay. Now again, what I remember is first function into second function. Okay, dx, isn't it? You have this kind of integral. I think while choosing first function and second function, you have some rule. Do you remember that one? Some eyelet rule like that, isn't it? Just Google it. Okay, I too don't remember exactly, but I remember some logic out of it. Is that okay? So first function should be chosen in such a way that if you take derivative, it should be reduced. Suppose if you have x square, if you take derivative, it will become x. If you take one more derivative, it will become 1 like that, isn't it? X square derivative is 2x, 2x derivative is 2. Like that, it will be reduced. That's how first function should be chosen, isn't it? So if you have this kind of thing, again, first function should be chosen carefully, first and second function, okay? So first function into integration of second function dx. And after this integration, you can apply the limit. Suppose if you have limit a to b, you can apply the limit a to b. So again, you don't have to write. You have to remember this one. That's what I do. Whenever I do, I do like that. First function, second function, like that. I do that one. Okay. So minus what is this one? Integration of again a to b. Integration of second function dx. Is that okay? Integration of second function dx, don't apply the limit, into differentiation of first function. or you better to take this dx outside. Yeah, integration of second function dx here only, differentiation of first function into dx. This is what I remember, and I'll not write this one always. Okay, I'll speak in my mind and I'll do the problem. Isolate the order that we have to choose, isn't it? Just go through that one. Okay, just go through that one, because I'm not concentrating on that part. If integral seems to be very lengthy, then we shall go for some technique, some trick or something, or direct formula. Yeah, I hope you. So, am I right about this one? Yesterday, I think I have given some first function into integration of second function minus integration of second function into differentiation of first function dx, isn't it? Like that. Yeah, now let me quickly apply this one. First, let me take this one, x into sin x dx. X into sin x. I'll take indefinite integral. Later we can take definite integral. Is that okay? So now look at here. This should be chosen as first function. Why? It can be reduced if you take derivative, because derivative of the first function will come, isn't it, later. So that's why let me choose this one as first function. First function into integration of second function sin x dx minus integration of second function sin x dx into, so differentiation of first function, that is 1 into dx, isn't it? So that can be written as x into minus cos x. You don't have to put separate integration constant here. Is that okay? You can put integration constant later at the end. So minus cos x minus, wait a second, sin x integration is minus cos x. Am I right? Yeah. Minus integration of minus cos x into dx. So that's equal to minus x cos x. So plus minus plus integration of cos x is sin x plus c. Am I right? So here it is very easy to do integration by parts, but if you have x cube into sin x, now it is lengthy doing this one, isn't it? It again, x cube differentiation is what is this one? X square, so 3x square will come. It will not be reduced in one step. So that's why again I have uploaded that video. Watch that one at least after the class. Okay. So what we can do in this case, the first function di rule. Am I right? Somebody told that one, di rule. First function should be differentiated, isn't it? That's what we do. X cube. Do the successive differentiation. 3x square. Then 6x. 6. Am I right? 3x square. 3 into 2x. Am I right? 6x. 6. And 0. Again, if you integrate, if you differentiate this one. Again, I'm trying to do this one. Okay, x cube into sin x dx. I'm trying to do this one. Is that okay? Now, again, let me take a second function. I need to integrate that one. Am I right? Sin x. What is sin x integration? Minus cos x. What is minus cos x integration? Remember, next step, you have to integrate minus cos x. Minus cos x integration is sin x. Minus cos x integration is minus sin x. What is minus sin x integration? Sin x integration is minus cos x. One more negative sign. That's why that is just cos x. Am I right? Again, cos x integration is sin x. Be careful. Okay, be careful. Then you have to multiply alternative signs here. So plus, minus, plus should start with positive and alternative sign. And you have to cross multiply this. You have to cross multiply this. It's a kind of trick. Definitely, if you cross multiply with the next one, that will be 0. You don't have to cross multiply. And collect the term and write that one. What is that one? X cube into minus cos x, isn't it? This one into this one, minus 3x square into minus sin x, plus of minus 3x square into minus sin x. Then you can apply limit. If it is definite integral, then you can apply limit. Minus 3x square minus sin x, am I right? So 6x into cos x. Six x into cos x minus 6 into sin x, am I right? Minus 6 into sin x. So minus x cube into cos x minus plus 3x square into sin x. Whatever the method you follow, okay, you can follow your own method if you have already what you call practice something. Okay, 6x into cos x minus 6 sin x. Any mistakes? Any mistakes? Just check it out. Bernoulli's successive integration. Okay. You have some other technique. U into V dash like that, isn't it? Yeah, successive. Yeah, the same idea, isn't it? The same idea. This should be differentiated successively. This should be integrated successively, isn't it? But sine of this one should be taken alternative. Sine of first part. That's what we do here. Writing that one systematically, then substitution. Okay, whatever you do. Okay. So I hope you can practice this one. Like that, do this one. X a cube to e power ax dx. So practice this one like in this way. X cube into e power ax dx. Which one you are going to choose first function? First function should be chosen like this. This one should be successively differentiated. Is that okay? Like that, apply and practice that one. And in this integration by parts, we have one more very famous integral, integration of log x dx. Isn't it? Integration of log x dx. How do you do this one? Actually, in the evening, in this place, we have little noise outside, okay? Noise outside. I think I'm shifting the place, okay? After that, this kind of noise will not be there. Early morning, there will be no noise because nobody will wake up at the time that we take class, isn't it? So we should take it as 1 into log x dx, am I right? Which one should be taken as first function? I think this one, because this should be differentiated, yeah. You have to write it as log x into 1 dx. Now look at here, log x into integration of second function. Second function is taken as 1 into dx. Is that okay? 1 dx minus integration of 1 dx into differentiation of first function, that is 1 by x dx. Am I right? So that's equal to log x into x minus, so that is x here, cancelled with this x, integration of dx, again x here. Am I right? X log x minus x. X log x minus x plus c. Is that okay? Let me start with some trigonometric integral. Suppose some trigonometric integral, okay? Then I'll go to substitution. Some trigonometric integral. So suppose cos square x into dx. How do you do this one? I think I asked this one when I call many people. DI rule can be again, it should be used in this case, okay? X cube into e power ax, like that, okay? Don't use, I think you don't have to use the DI rule if it is very simple. You can do it in one step. I don't think there is any exception or something, okay? I haven't worked properly on that one. I just have taken those things. So mathematics, I will not worry much, okay? If I know the method, that's sufficient for me. Is that okay? I should be able to solve all integral, that's it. Yeah, so whatever the method you choose. Yeah, cos 2 theta formula, am I right? So what is cos 2x formula? That's equal to cos square x minus sin square x. That can be written as 1 minus 2 sin square x, isn't it? 1 minus 2 sin square x or 2 cos square x minus 1. Am I right? If you solve it for cos square x that's equal to, so 1 plus cos 2x whole divided by 2. So similarly, if I solve this one for sin square x, because if you want to integrate sin square x, that's equal to 1 minus, am I right? 1 minus cos 2x whole divided by 2. So that's why that is nothing but the integral of 1 plus cos 2x whole divided by 2 into dx, isn't it? So that's equal to integral of, again I'll take 1 by 2 outside, so dx plus integral of cos 2x dx, am I right? So 1 by 2 outside, integral of dx is x here. What is cos 2x integration? Sin 2x by 2 plus c, isn't it? I hope you can do this one. So similarly, do integration of sin square x. Okay, then later I will go for by substitution, integration by substitution. Is that okay? Yeah, again that can be done by substitution. Cos square x into sin x. Yeah, wait a second. I'll go to that one later. I'm just concentrating some trigonometric integral. So cos cube x into dx, sin cube x into dx. I better to give the hint. You better to work out, isn't it? So how do you do this one? Cos cube x into sin cube x. Cos 3 theta formula. Cos 3x is equal to, any idea? Sin 3x is equal to 3 sin x minus 4 sin cube x. Cos 3x is 4 cos cube x minus 3 cos x. Are you sure? From this equation, solve it for cos cube x, it will be in the linear form. If you solve it for cos x and cos 3x, combination of cos x and cos 3x. From this one, solve it for sin cube x, it will be in sin x and sin 3x. That's one of the method. Other method is cos cube x, you can write as, yeah, what is the other method? Cos square into cos x, isn't it? Then cos square x you can convert like this, but then again that will be little lengthy, isn't it? You better remember these two formula. No, again cos a into cos b formula will come. You have to again do that one. Again, one more trigonometric formula will come. That's what I'm. Yeah, I think substitution. That's what I. Yeah. Okay. Yeah. Look at here. What it's saying is cos square x into cos x dx. Yeah, that's correct. Cos square x you can write as 1 minus sin square x. Yeah, you can do substitution. That's also easy. Into cos x dx. First integral is cos x dx. Second integral is sin square x into cos x dx. Is that okay? Like that you can do. Yeah, I better to get into some other type of examples. A kind of substitution. That's the best idea. Yeah, cos cube x. Let me do it like this. Again, you do in this way. Let me do as he said. Okay. So that's equal to cos cube x. Again, a kind of practice, isn't it? Integral of cos square x into cos x dx, isn't it? So that's equal to, so 1 plus cos square x, I am going to write a sin 1 minus sin square x into cos x dx. That can be written as integral of cos x dx minus integral of sin square x into cos x dx. Here comes the substitution. So first part you can do directly, isn't it? What is that first part? Integral of cos x dx is sin x or minus sin x? Sin x. So minus, what you have to do here is, in this part of the integral, so substitute sin x is equal to t. I hope you know how to do integration by substitution, isn't it? So then cos x dx is equal to dt, isn't it? I'm just trying to do only this part, okay? This part, look at here. So integral of sin square x into cos x dx. So if you put sin x is equal to t, so then if you differentiate this one, cos x into dx is equal to dt. After some practice you can write it directly. Now if you substitute, that will become, actually if it is definite integral, you should change the limit also. If you substitute, you should change the limit also if it is definite integral. Since it is indefinite, again I can resubstitute actually. I can change the variable, then I can resubstitute, I can write in terms of x only later, isn't it? So that's why, what if I do this kind of substitution, what will happen? Yeah. Integral of t square into cos x dx is dt. That is nothing but t cube by 3 plus c. What is t? Sin cube x by 3 plus c minus sin cube x by 3 plus c, isn't it? By substitution. This is a kind of substitution. I hope you know some part. Like this, let me take some more examples on substitution. Suppose if you have integral of sin raised to phi x into cos square x dx. Can you do this one? Integral of sin raised to phi x into cos square x dx. What is the best idea? Yeah. Sin cube into sin square. Somehow you should convert it into integration by substitution because that is easy. Yeah. Sin power 4x into cos square x into sin x dx. No, sin power 4. That can be done. You can write it as sin square the square, sin square x the whole square. You can write it as 1 minus cos square x the whole square into cos square x into sin x dx. Am I right? Now you can put cos x is equal to t, isn't it? Minus sin x dx will be equal to dt. Again, it needs practice even for me. Okay, look at here. Now what I do is cos x is equal to t minus sin x dx is equal to dt. That means sin x dx is equal to minus dt. Isn't it? Sin x dx is equal to minus dt. If I substitute this one, if I substitute that one, what would happen here is integration of 1 minus t square the whole square into t square into minus dt. Now just square that one and integrate. Isn't it? And later we can substitute t is equal to cos x again. Sometimes if you have definite integral, if you do some substitution, you you better to convert it into back into original form, and then you can apply original limit only. You don't have to change the limit. If you want to use the new variable, then you have to change the limit. Let us do some of them. So similarly, take some more examples, okay? Just like integral of sine raised to 4x dx. So integral of tan raised to 6x into secant raised to 4x dx. Integral of tan raised to 5 theta into secant raised to 7 theta d theta. Integral of tan cube theta d theta. Similarly, integral of secant cube theta d theta. Do this as a practice. X square into a root of x square into root of x square plus a square. Let me take it like this. Dx. Again, I'll give the list of standard substitutions here, standard trigonometric substitution. If you have this kind of what you call situation, you should substitute x equal to a tan theta, so that you can get rid of that root, isn't it? If you substitute x equal to a tan theta, then what is dx? Tan theta differentiation, secant square theta d theta. Am I right? So now if you substitute, what will happen is, if you have limit, according to this substitution, you should change the limit, okay? Or you can keep the old limit, but you should convert back to tan theta again. We shall solve that kind of problem again while doing application. Is that okay? So now look at it, that's equal to integral of x equal to a tan theta. That's what I have. So 1 by a square tan square theta, root of x square plus a square. Am I right? A square tan square theta into plus a square. Now take that a square common, take it outside the root. So what will happen? So that's equal to 1 by a cube, a square here, one more a will come out here. Integration of 1 by tan square theta is cot square theta. Let me write it. 1 by tan square theta is cot square theta. Is that okay? So this one is root of 1 plus tan square theta. That's equal to secant square theta. Am I right? Look at it. Or let me keep it here. So tan square theta. 1 plus tan square theta is secant square theta. Am I right? Secant square theta under root, that's equal to secant theta. Wait a second, I haven't substituted dx actually. Wait a second, that's wrong. So what is dx here? Dx part here, a into secant square theta d theta. One more a is here. Don't forget any of this part. Dx should also be substituted, okay? So 1 by tan square theta into secant theta into secant square theta d theta. So tell me if I am wrong. 1 by a square integral of cot square theta means actually cos square theta divided by sin square theta into what is this one? Secant theta. One of the secant theta remained, 1 by cos theta. Any other way? I think one of the cos theta got cancelled. That is equal to 1 by a square integral of cos theta by sin theta into 1 by sin theta. Can I write like this? Cos theta by sin theta into 1 by sin theta. Cos theta by sin theta is cot theta. 1 by sin theta is cosecant theta d theta. I think this is cosecant theta derivative. Cosecant theta derivative is cosecant theta into cot theta, isn't it? That's equal to 1 by a square minus 1 by a square cosecant theta d theta. That's not over. Wait a second. That okay? That's not over. Now look at here. If you have changed the limit, you can use the new limit and you can substitute the limit. Sorry, not d theta plus c. Isn't it? Cot theta, cosecant theta minus cosecant theta by a square. Yeah, that's correct. Plus c. Am I right? Now, what we usually do is, what I prefer is, I convert back in terms of x actually. That's what I prefer. Is that okay? What I have substituted x equal to a tan theta. Isn't it? X equal to a tan theta. What is my answer? Answer of this integral, actually it became in terms of, so minus 1 by a square. What is this one? Cosecant theta can I write as 1 by sine theta plus c. Am I right? So tan theta from this substitution, that's equal to x by a. Now let me go for right angle triangle. If this is theta, this will be x, this will be a. Am I right? Opposite side by adjacent. That this should be equal to x square plus a square. Am I right? This should be equal to x square plus a square. Then from this one, define sine theta. What is sine theta? Opposite side by x by root of x square plus a square. You have 1 by sine theta here. Am I right? You have 1 by sine theta here, minus 1 by a square. 1 by sine theta means reciprocal of this one. Root of x square plus a square whole divided by x plus c. Practice this kind of integral. Now I'll give some expression and standard substitution. Look at here. I mean, if you have this kind of expression, this kind of substitution can be used. Okay. So expression, substitution. While doing the substitution, actually, again, some range also does matter. Let me write it down. Substitution, identity that may be required. So root of a square minus x square. I'm listing only trigonometric substitution. Okay. So as a homework, you list out hyperbolic substitution. Sometimes hyperbolic substitution is required, isn't it, for some integration. I'm doing trigonometric substitution. Yourself work out hyperbolic substitution. Okay. Root of a square minus x square. Yeah, can you send one message? Live with the same link. I'll upload NCERT chapter again. So I'll practice with that one. Okay, NCERT textbook. That's the best idea. If you have root of x square minus a square, then you have to put x is equal to a secant theta, where identity is secant square theta minus 1 is equal to tan square theta. We should get rid of a root, isn't it? So like this, list, these are trigonometric substitutions, okay? Like this, list out hyperbolic substitution, situations of hyperbolic substitution. Is that okay? So again, partial fraction is very rare, but still you can. So do couple of problems from NCERT textbook. Okay, let me upload NCERT textbook. Okay. Now, as a homework, do this problem with integration by substitution. Do this one. What is this one? Integral of x dx whole divided by x square plus a square whole power 3 by 2. X equal to a tan theta again. Is that it? Similarly, integration of dx divided by x square plus a square whole power 3 by 2. Do these two problems by substitution, x equal to a tan theta substitution, and practice that one. And try to prove this one also. Look at here. Integral of dx divided by root of a square plus x square. Look at the answer. Log of x plus root of a square plus x square. Then what will you do? If you substitute tan theta, will you get logarithmic? You should do some hyperbolic substitution. That's what I'm saying. Only hyperbolic can be converted into logarithmic. Can you? So try this one. If you feel it is difficulty, post it into Slack. Okay, somebody else may solve, or I'll solve it tomorrow. Hyperbolic substitution, isn't it? Otherwise, trigonometry you can't convert into logarithmic. Hyperbolic are related to exponential. Exponential can be so converted into logarithmic, isn't it? I think. I had given, yeah, look at here. I had given these three. Do you remember? Sine hyperbolic inverse x is equal to log of x plus root of x square plus 1. So try to prove this one also. Try to prove. Try to prove this one. So cos hyperbolic inverse x is equal to log of x plus root of x square minus 1. So tan hyperbolic inverse, I think yesterday I gave this one, am I right? Yesterday or day before yesterday, I gave this one actually. So half of log of 1 plus x divided by 1 minus x. So that's why I'm thinking some hyperbolic substitution will lead you to this kind of answer. Try to do this one by substitution, okay? That's sufficient. Again, while working out differential equation, we will get to now, okay? Yeah, let me do one more problem. That's best idea. Let me do one more problem, okay? Last problem. One definite integral problem, okay? Definite integral of 0 to 1, okay? 0 to 1, tan inverse x dx. Don't write 1 by 1 plus x square, that is differentiation. Isn't it? Not integration, isn't it? Then how do you do this one? First you should do integration, isn't it? Try with integration by parts. Again, I'm guessing. Okay? I'm guessing. So let me take tan inverse x 0 to 1. Tan inverse x into 1 dx. So that's equal to first function into integration of second function. What is this one? Integral of dx. After doing this one, you can substitute the limit. I hope you know that one in integration by parts. So when you have to substitute the limit, minus integration of again 0 to 1. So integration of second function, that is 1 dx, isn't it? Into differentiation of first function, that is 1 by 1 plus x square dx. Check it out. So this is nothing but x into tan inverse x. X into tan inverse x running from 0 to 1. Running from 0 to 1 minus, this is x here, integral of 0 to 1 x divided by 1 plus x square dx. This is the best exercise. Best exercise. We will do integration by substitution also. Look at here. How do you do this one? Don't put again x equal to some tan theta or something. So that can, again, if you have under root, then only you do that one. Numerator is differentiation of denominator, isn't it? So you can substitute for denominator. Now let me do the substitution here. Upper limit 1 into tan inverse 1 minus lower limit 0 into tan inverse 0, that's equal to 0 actually. That is first part, minus integral of 0 to 1. Look at here, this part, for this part I will do the substitution here. 1 plus x square is equal to t. I will substitute like this. 1 plus x square is equal to t. Okay. Then if you differentiate, 2x dx is equal to dt. But you need x dx here. That's why x dx is equal to dt divided by 2. Now once you change the variable, you should change the limit also. Am I right? When x equal to 0, isn't it? When x equal to 0, x varies from 0 to 1. Am I right? Then how t varies? When x equal to 0, t equal to 0. Now look at it. When x is equal to 0, sorry, t is equal to 1, not 0. Am I right? When x equal to 0, t is equal to 1. When x equal to 1, what is t? 2. If x varies from 0 to 1, t varies from 1 to 2. That's how you have to change the limit after the substitution. Isn't it? So minus, look at here, integral of, I am changing the variable to t, that is 1 by 1 plus x square into x dx is dt by 2. But t varies from 1 to 2. T varies from 1 to 2. Isn't it? Let me continue here. Actually, I have to spend some time on how to use board properly. Earlier I was using that part of the board. Now I can't go over there, isn't it? If I focus much area, then for smartphone, it will be a little bit problematic. I mean, you can't watch that one on smartphone. That's not comfortable. Yeah, anyway. So that is sufficient. If I hold a duster in one hand, I can do it, isn't it? Ultimately, your answer is tan inverse of 1. What is that one? Pi by 4, isn't it? So that's equal to pi by 4. So pi by 4 minus 1 by t, 1 by 2 outside, 1 by 2 outside, 1 by t is log t, ln of t. Be careful. Be careful. Log of t running from 1 to 2. Let me do further steps here. So pi by 4 minus half of log of upper limit minus, what is log 1? In definite integral, there will be no integration constant, okay? Indefinite integral, because after substitution of limit, again, this is a kind of area under the curve, isn't it? You should get some exact value. There will be no arbitrary constant, integration constant. Okay, don't put any c here. Pi by 4 minus log 1 is 0. So log 2 by 2. Try to do it again. So look at it. Integration of 1 by x square dx. Then you can write x raised to minus 2 dx. You can write as x raised to minus 2 plus 1 divided by minus 2 plus 1. That formula works only when x, this power which is not equal to 1, minus 1. I mean, it will not work for 1 by x. For 1 by x, it should be log. For all other powers, either negative or positive power, it will work.